Sounds hard to believe that this question can be answered in less than a minute. Yes, it is true. But there's one condition. You need to know thoroughly the basic concepts in logarithm. A few basic concepts that will help us tackle this problem in less than a minute. The basic definition of a logarithm is presupposed when I work out the solution. But the few concepts we need for this, I will take you through. Before I dive into the solution, please like and subscribe to my channel. As you know, logarithm of 10 to the base 10, logarithm of any number to the same base is 1. Now let's find out logarithm of 100 to the base 10. For that, write 100 as 10 square 10, and this is equal to 2 log 10 to the base 10 using the power rule. Power rule means log 8 power m equal to m log a. This is power rule. Using that, I have taken 2 to this position. Now log 10 to the base 10 is, as you know, is 1. And 2 into 1, which is 2. Rather, this is what you get. Log 100 to the base 10 equal to 2. You might be wondering why I found out these two logarithms. Let's look at any two-digit number. Let x be a two-digit number. If x is a two-digit number, as you know, it lies between 10 and 100. Of course, don't put equal sign. 100 is a three-digit number. Basically, it ranges from 10 to 99. Now take logarithm of this inequality. You get log 10 to the base 10. I'm taking logarithm to the base 10. Log x to the base 10. 100 to the base 10. This implies this is 1. Let me write log x to the base 10 as it is, and this one also we have found that to be less than 2. So this implies what? Logarithm of x to the base 10 lies between 1 and 2. Rather, log x to the base 10 will be a number above 1 and below 2, which you can write like this: 2 point some decimal numbers. We are not interested in the decimal figure because that won't be needed for finding the number of digits in the given problem. Let's focus on the integral part. That's 1 here. So this is what you can observe. If x is a two-digit number, logarithm of x to the base 10 will be 1 point something, and this 1 is called the characteristic of logarithm of x to the base 10. Characteristic of log x to the base 10. Maybe you remember studying these things in the high school class. There is another word for the decimal part, that is mantis. Anyway, I don't want to go into those areas. Now we will extend this principle to a three-digit number. Here we have looked at a two-digit number. Now let's look at a three-digit number. Let x be a three-digit number. That implies x lies between 100 and 1000. Now, like we did before, take logarithm of this inequality. You will have log 100 to the base 10 log x to the base 10 and log 1000 to the base 10. This implies what? Log 100 to the base 10, we have already seen that to be 2 here. Can you see that? Now, less than or equal to log x to the base 10. Now there comes log 1000 to the base 10. Can you guess what this would be? This is 3 actually. I will show you in the margin. See, look at this. Log 1000 to the base 10 is log 10 cubed 10, that's equal to 3 coming down using power rule, and this is what? 3 into 1, and that's equal to 3. So let me substitute 3 here. Now what do you see? Logarithm of x to the base 10 lies between 2 and 3, and x is a 3-digit number. Rather, log x to the base 10 equal to any number lying between 2 and 3, you can take it as 2 point something. And here x is a 3-digit number. Now look at this. This 2 is called the characteristic of, as I showed you before, log x10, where x is a 3-digit number. So you can see a pattern emerging from these two examples I showed you. If x is a 2-digit number, characteristic is 1. If x is a 3-digit number, characteristic is 2. That means if x is a 4-digit number, the characteristic would be 3. Rather, you can generalize the whole thing. See, if x is an n-digit number, of log x to the base 10 will be equal to, can you tell me? Yeah, it would be n minus 1, 1 less than the number of digits. Put it in the reverse format. If you find out the logarithm of a number, and if you can see the characteristic from that, the number of digits will be 1 more than the characteristic. Characteristic will be 1 less than the number of digits, and the number of digits will be 1 more than the characteristic. Now let's come to the actual problem. Using power rule, 1000 comes down, log 2, that's equal to 1000 into log 2, to the base 10, of course. Log 2 to the base 10, it's already given in the problem. Log 2 to the base 10 is given to be 0.3010. Let's substitute that value here. 0.03010. This on multiplication, you will have 301.0. In fact, this is an approximated value of logarithm. The correct value will go on. It's a non-terminating decimal number. So there will be a few more numbers here, and you will be getting 301 point some other numbers. Anyway, as I told you before, we are not interested in this part. 301 is the characteristic of logarithm of 2 to the power 1000. Rather, if 301 is the characteristic, as I said before, 2 power 1000 will have how many digits? 301 plus 1 equal to 302 digits. Can you see this? So to find out the number of digits in a huge number like this, you take logarithm, then use logarithmic table. These values are arrivable from the logarithmic table. In an exam, they will of course provide these values to you for a question like this, and substitute here, simplify, you get the characteristic, add 1 to that, you get the number of digits. This is how you find out the number of digits. So all you need to know to solve this problem is this result. If x is an n-digit number, characteristic of log x to the power 10 is n minus 1. That's all you need to know for answering this question. And all the time you need is the time for mere simplification of this simple calculation thing, which you can easily do. Maybe you won't take even 1 minute. So I hope you understand why I said in the beginning, you can solve this problem in less than a minute. As you know, time is a big constraint. You don't have the luxury of writing too many steps because there's no time in competitive exams. So if you are well versed in the basic principles of these different topics in algebra, you will be able to tackle the problems fast enough and get to the answer soon enough. If there is any point you are still unable to follow in the solution, please drop your comments. And if you found this video useful, share it with others also so that they can also benefit from it. And don't forget to press the bell icon so that you won't miss out any of my videos showing smart solutions to tricky problems of this kind. Thanks for watching and see you in the next video.